All right, hey there, it's Christian, and I gotta show you this because this is super cool. I'm gonna switch colors and I'm gonna go to, well, let's see, let's just switch to green. So we do have this 15-volt battery, and we're gonna say we're going to go from this side of the battery up and then around, and we're gonna use this blue path for our first loop. When we do that, we know that voltage is equal to the current times the resistance. So we're going to just take the 6 ohms of resistance and multiply it times our current, which is I1. And because we are moving in the direction we want to move, we know that that's negative 6 I1. Then we go to the next resistor, so negative 6 I2, and then here's kind of the trick. This one is also 6, but notice there's no current label for it. But it would be exactly the same as I1 because these are both directly connected to the battery, so they should both have the same current. For the next part, we're going to look at the 12-volt battery, and we're going to move this way in the circuit, and we're going to say that when we go that way, we are basically, I need to pull another red here, going through, and this would be negative 9, so we're losing 9 volts of potential times I5. I'm sorry, uh, this would be negative 9I5, not because it's it is losing potential, but it's negative 9 because it's 9 ohms. So negative 9I5, and then we're going to come over, we're going to go up, and notice that now we are going against this other current. So this one now becomes positive 6I2. And then we come back up and we're going across I3 now. And we see that this one is negative 2.4 I3. So this one's positive because it's going against the direction of current that is listed for what we have. The last loop is starting at the battery, and we go through again the negative 9 I5, and then we go up through this resistor. And remember, this resistor, the current I4 is traveling down to the left, but we're going against that. So that's why this one is positive 6 times I4. Now that we've done all those and we recognize what everything is, we can go through and use our equations in order to figure out exactly what I1, I2, I3, I4, and I5 are. So now we have our equations for all three of our, well, we have all three equations for the circuit. I1, we know because of the junction rule, is equal to I2 plus I3, and we know that I3 is equal to, here where we're splitting this junction, is equal to I4 plus I5. Then if we start at the battery, we're going to make this battery, since we're going this way from positive to negative, we're going to make this negative 15 is equal to negative 6i minus 6i2 minus 6i1. And remember, because these two are the same, we can add them together, and we have negative 12i1 minus 6i2. For the other side, because we're starting at the negative end of the battery and going towards the positive, we're going to say that that's a positive 12. And we're going to lose 9I5. We're going to add 6I2 because remember it's going in the opposite direction there of the current flow here. So minus 2.4I3 for that one. And then for the last one, we've got this little, and so that little loop there. So we've got positive 12. We're going to lose 9I5. Then we're going to add back 6I4, which is here. That's all fine and dandy, but nobody wants to do that by hand, so you can do it one of two ways. I went into Desmos first, and I went to the matrix calculator and plugged all my values in. The thing I want you to notice here is we've got all of our numbers in, and this 12, remember, comes from the fact that we have negative 12 here, because I1 is doubled in that one since we've got two of the same thing going on. Other than that, all the other numbers are just as they appear in the equations. And then here we have to remember to do negative 15 and positive 12, positive 12. And when you solve that, you have to do the inverse of all your A values. Because remember, we're multiplying two things that are inversely related. So in the matrix, what you have to do is A to the negative 1 power, and then multiply that times your B values, and that will give you the correct answers here. If you do it in the TI-84, you basically just go in, you're going to say second matrix. You're going to go to edit. So I want to go over to edit. You'll have to tell it you want a 5 by 5 matrix. You're going to put all those values in again. And then you're going to do second matrix. We're going to go over and edit our B values. And so now we've got our B values in there. And then finally, we're going to quit out of that mode. And then we're going to do what you see here. So we're just going to say set second matrix. We're going to choose number 1. So you hit enter right off the bat. We need to do the inverse. So we hit the inverse button. Times, and then we're going to do second matrix, and we're going to go down to B and hit enter. And we're going to enter again, and voila, there are our values. So that is how you go through and solve the killer circuit using your calculator, using Desmos, and making sure that you have your loops and your junctions correct.